Scientific notation is a handy way to express numbers, since it allows you to deal with a wide range of numbers. So on to the solutions. So just write the number 0.000002 using scientific notation. Two times 10 to the power of minus 6. So that's the way we express things using scientific notation. You have a coefficient, in this case 2, so that would be the digits that you see, multiplied by 10 to the power of some number. So in this case it's minus 6, because the first, if it was 10 to the power of 0, we'd be dealing with the units digit. That would be minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So it's the minus 6th digit. And it's the same for all of them. So express that. Well, the digits are going to be 92049. Then that coefficient is a number which is less than 10. If it was greater than 10, we'd shift it a bit. We just add 1 to the exponent here, and we'd end up with a digit, a number which was less than 10. So we want 9.2049, because that has all the information, multiplied by, well, that's 10 to the power of 0, 1, 2, 3, 4, 5, 6, 7. And the same thing for the last example. So we only have a digit of 3, and it's in the 10 to the power of 8 slot. This is needed because when you're dealing with, say, scientific stuff, if you're talking about chemistry and you have Avogadro's number, so how many molecules are there in a sample that you have, that's 10 to the power of 23. So you wouldn't write that out in full. It would be an absolute mess if every line you're writing pages. Also, you're not typically that accurate. We don't know things to like 5, 6, 7 decimal places most of the time. Typically we just want 9.2 times 10 to the 7, because, you know, that's roughly how accurate we are. But of course it'll depend on context. So now we get to the core of the lesson, which is sequence and series. That is on the goal list. That's one of the questions. Sequence and series, complex numbers, volumes and areas. They are asked pretty much every time. So you know that the work that you put in gets rewarded. So there's no excuse not to have totally mastered sequence and series and complex numbers, as well as volumes and areas. So on we go. We begin with sequences. So sequences are just lists of numbers. In particular, we're interested in arithmetic sequences, which are a very particular form of sequences. For arithmetic sequences, you start with a number and then you add or subtract a certain number to get the next number. And you just keep repeating. So for example, if you have 1, 2, 3, 4, 5, 6, your counting numbers, or whatever you want to call them, they'd be an arithmetic sequence. You're starting at 1 and you're adding 1 to get the next number. And when you're at 2, you add 1 again to get the next number, and so on. Here we're looking at notation. So for each topic we're going to introduce some new notation. It's jargon. It's a way, it's the shorthand, it's the way that we write down things. So with sequences we use something like this, where we have T, since it's the term. So if you have a sequence 1, 2, 3, 4, 5, 6, the first term is T1, then T2, then T3. Though unfortunately some people start at T0, then T1, then T2. But we'll go into that later. So if you write down Tn is equal to 7n minus 2, then we can write the first 3 terms out. So if the first term is T1, then we just substitute 1 for n. So we end up with 7 times 1 minus 2, which is equal to 5. Here, since it's 7n, when n increases by 1, when we move to the next term in our sequence, we're going to jump by 7. So we started at 5, then we add 7 to get 12, add 7 to get 19. Though you could write this out in full. You could go, oh, T2, the second term, is 7 times 2, which is 14, minus 2 is 12. So it's just getting familiar with using this kind of notation. The next question is the same thing. So Tn is n plus 5. When n is equal to 1, that's 1 plus 5, which is equal to 6. Since Tn is equal to n, when n increases by 1, this expression increases by 1. So to get to the next number, we just add 1, we just add 1, and we just add 1 to get the fourth term. Another concept is the common difference. So remember I said for an arithmetic sequence we add or subtract a certain number to jump to the next term in our sequence. That's all. That number that we add to get the next term is called the common difference. So it's purely a term, so that we can just say the common difference and we know what we're talking about. So if the sequence is 5, 7, 9, well, we can see the common difference is 2. You can take any term in the sequence, subtract the previous term, and you get the common difference. Same thing again for next question. So, well, I can see I'm jumping in steps of 5. So the common difference is 5. Here we work the other way around. In the first two questions, we were given a general expression for Tn. So we can write down the 50th term, the millionth term, by just writing a million for n. Here, we're given numbers in the sequence, and we're trying to get the general term, Tn. Well, we can see that the common difference is 4. So it's going to be Tn is equal to 4n. And then we just put in another term to match with the value of what the first term is. So since the first term is 3, Tn is equal to 4n minus 1. Makes sense. If the first term is called T1. As I said, unfortunately there is no universal acceptance of what the first term is. So you could also have written 3 plus 4n if the first term was T0. Same thing again for the next question. So decide whether you're using T0 or T1. I'm going to use T1 for the first term. I can see that the common difference is 2 since it's increasing by 2. So Tn is going to be equal to 2n minus 1. So how did I get the minus 1? Well, I want T1 to equal 1. So then I can just put in 1 is equal to 2 minus some number. So that's how I end up. I go, oh, if I put in minus 1, then it works. If I say that the first term is T0, then I need to do 1 plus 2n. So then we move on to series, and in particular the summation formula. So once we're familiar with sequences, we're able to actually come up with this formula which tells us what the sum of n terms from an arithmetic sequence are, which is pretty impressive. I was not expecting it as far as I remember. So I've just tweaked the question a little bit because you were just the original question was use the summation formula. I've added the formula. So Sn is n over 2 times 2a plus n minus 1d. So where a is the initial term and n is, well, Sn. So what I like doing is trying it out on a very simple example where you can see what's going on. So say we were looking at 1 plus 2 plus 3. You can do that in your head. So how would I describe that as an arithmetic sequence? Well, I'd say n is equal to 3 because, well, there are 3 numbers. A is equal to 1. That is the initial term. D, which is the common difference, is equal to 1, since I'm jumping in steps of 1. So now I just plug in those numbers into that formula to see whether I got it right, whether I can understand whether my understanding of what's going on is correct, so I can feel more confident about it. So the formula says, with these values, that S3 is 3 over 2 times 2 times 1 plus 3 minus 1 times 1. Work through that, and I get it's equal to 6. And as I said, for this simple example, I can do it in my head. I know that 1 plus 2 plus 3 is equal to 6. So we're on. It's working. My understanding of this formula seems to work. What is the sum of the first 40 terms given that Tn is that? Well, the first 40 terms, so that would mean n is equal to 40. The common difference, I need the first term and the common difference. I'm going to say the first term is T1. And the common difference would be 2. It would be the number in front of the n. I'll see what I did. So, yes, n is 40. A is equal to 4. That's the initial term. So n is equal to 40. A is equal to 4. And D is equal to 2. So that's, I'm adding 4 plus 6 plus 8 and so on. And just as a quick check, say n was equal to 2. I was just adding 4 plus 6. Then I'd have 1 there. 2 times 4 would not be changed by the fact I'm now using n is equal to 2. If n was equal to 2, I'd have 2 minus 1 here. So I'd just have 2. So 2 plus 8 would be 10. That's 2 over 2. So I'd end up with 10. So S2 would equal 10. My initial term is 4. So that means I have the actual sequence I'm dealing with is 4 plus 6 plus 8, or 4, 6, 8, and so on. So S2 should equal 10, and this is working. So in a way, so here the sequence is 4, 6, 8, and so on. So the first term is T0. So then I just work out this expression. So 40 divided by 2 is 20, and I get 1720. What is the sum of the first 100 terms from the arithmetic sequence 5, 7, 9? Well, I have 100 terms. The initial term is 5, and the common difference is 2. So D is equal to 2. So then I plug that in, and I get 10,400, which is far easier than if I try to add all the numbers. And I'd most likely make a few mistakes, if you're adding 100 numbers. That's all you can pretty much be asked. This actually has two kinds. One where you're given the general term and are told to work out the summation from that. So you need to work out what n, a, and d are given your expression. Or you're just given the actual terms in the sequence. So then you need to be able to extract what n, a, and d are from those. Plug them in and you're done. Remember to subscribe to be sent the problems and solutions when they're put up.